Hello everyone, welcome back to our class of business statistics. In the previous class, we discussed about the graphical representation of the measure of central tendency, which are mean, median, and mode. In this lecture, we will be covering the comparatical analysis of all three measure of central tendency. So, how mean, median, and mode differs from each other, and how these can be compared with each other, and also which type of measure is suitable in which type of scenario. So we will be comparing all these three measures together, and the key learning goal is now how to calculate them, how to differentiate one from each other from another, and to know the properties of each of these type of measure. So let us move down deeper into it. So what is central tendency? Tendency is nothing but finding out the middle value of the data set, and it emphasizes on what? Finding out the mid value or a center of a data set. And for measuring the center point of the data set, we use mean, median, and mode. Whereas mean is a arithmetical average, median is a positional average, and mode refers to the repetition of values, which means high frequency, right? Or your highest frequency. Mean has its merit and demerit. Mean is good when you are dealing with ratio data or interval data, but it's not fit for nominal data or categorical data. Another problem with the mean is, like, mean is affected by the outliers or extreme value, and it is not suitable when data is skewed. So mean is good. It will give you a very robust and very good result when your data is continuous data and you do not have too many outliers in your data, or your data is symmetrical. But it is not suitable if you are dealing with categorical data and when there are a lot of outliers in your data, or there are outliers in your data. Median in turn is good when your responses are relative rather than numerical. Means your responses have, have a relative strength rather than arithmetical strength. For example, like when you are measuring um, the satisfaction level, as you are doing with the Likert scale, or you are finding out how any drug is effective. So you are asking the patient how you're feeling today. Obviously, your responses will be like, I'm feeling better than earlier. I'm feeling little bit better. I'm feeling quite better, rather than the quantified value for uh, the responses. So therefore median is a good measure. Or whenever you have rated some services, say you have visited a hotel and they want you to rate them, or you have taken any service and you want them to rate you on satisfaction level, or from say 0 to 10, on the scale of 0 to 10. In this case, what will happen? So if they have rated you from 0 to 10, so you can easily say, if the median is 5, right? So if your median score, obtained score, is less than 5, then you can say the customer is not satisfied. Say for example, your median score is 4, and if the median score offered by uh, the rating giver is, say, more than 5, then you can say majority of people are satisfied with your services. So you can use median there also, right? And you can use the median when outliers are there, because there is no point, like if you have outlier in a data. Say I am taking the pocket money of 3 students into consideration, and these 3 students have the pocket money of, say, 1,000 rupees, 500 rupees, 1,500 rupees, 2,000 rupees, or I can say 3,000 rupees, and 1 lakh rupees. If I'm handling this problem with the mean, then what will happen? This one outlier or extreme value will actually I'll increase my mean to a great extent, will affect my mean to a great extent. For example, if I'm going to take the average pocket money of a student, in this case, it is 1500, 3, 6,000, 1 lakh, 6,000, which will give me the average pocket money of these 5 students as 5 to the 10, 21,200. So is it a representation of all this population, all this data which is given to you? If I say that average pocket money of student in this class is 21,200, and accordingly you offer them something, so any product, because on an average student can spend 21,200. Is it a reality? It's far from reality. Why I get a faulty measure or representative of this data set as a mean? Because our outlier has actually taken up the mean, and it has actually affected the mean to a great extent. It pushed up the mean to the level of 21,200, whereas the concentration is somewhere around 2,500. So that this is why mean cannot be used. One, you have the skew data, or extreme values are there in your data set. But if I'll deal the same problem with the median, then simply I'm going to assign them the position. So, what I'm going to do, I'm going to assign them the position. Like, this is the first position, second position, third position, fourth position, and fifth position. If you have 3,500, then also it will be assigned the fifth position. And if you have 1 lakh, it too will be assigned the same position, fifth position. So the effect of outlier, which is 1 lakh, will not be affecting the value of the median to a great extent, because we are not taking the mathematical value of fifth number, which is 1 lakh, into consideration while calculating the median. Because median is like what? My mid value, which is 1500 in this case. And this is not affected by 1 lakh, because I'm simply mentioning it as fifth number. So median is good for this type of cases. Then coming to the mode. Mode again is suitable for this type of problem, because now I'm concerned about the repetition. So there is not repetition. So I can say no mode is there. But if I have one more student there offering 15, having a pocket money of 1500, then I can say my mode is 1500. So mode is okay when you are dealing with you want more numbers to uh, to cater. So if you want to attract the student, or you want to find, you are interested in finding out which amount maximum number of students are getting as a pocket money for 1,000, 1,500, or 2,000, then mode will help you out. So mode is suitable for categorical data, and it is okay with the outliers. But mean is not okay with this outlier. But mean will give you a more robust result, and it is widely used in the industry, because it has a very powerful mathematical property when you're dealing with the proper quantitative or ratio data, right? So all the three measures have their own importance and limitations. Whereas categorical data use median and mode. mathematical data or calculative data, mean is considered as a better measure of better representative of measure of central tendency. Now, let us take all these three measures one by one. So first is like mean. So what is the definition of the mean? Some of it is actually a representative, mathematical representative of all the values in the data set. So you are actually concerned with finding out a single representative of all the values in your data set. So mean is how you're finding out the mean. You are actually summing up the number and dividing it by number of observations, which is n, and the resultant is mean. Mean is actually what meaning is telling you that you have to club all the numbers together and then you are dividing it or distributing it among all the values equally, then mean is the answer. For you, some are having suppose you want to collect the pocket money given to each student. You collect it to a common pool and then distribute an equal amount to all students, then your resultant answer is mean. Actually, the money which you will be distributing to each student is a mean. So mean is actually a or one representative which will be distributing the values equally for all the observation. But it is not suitable when outliers are there and when your data is categorical data or you have the non-symmetrical data. Coming uh, to the next measure, which is like median. So defining the median, median is positional made of the data set. It actually is a value which lies in the mid. So half of the values are there, half on the right. So zero is your median. So median is actually something which is in between if your data is arranged in ascending or descending order. When median is the best suitable measure, when your data is skewed, you are handling a skewed distribution or your data has the extreme value. The strength is like it is resistant to the extreme value, and also another strength of the median is that it will help you to deal with the relative numbers, relative responses. For example, and we have taken an example of like when you're measuring this satisfaction level. Suppose I want to measure your satisfaction level, how satisfied you are with this lecture. Then that way that and I want one number to find out your satisfaction level. Then median will help me out rather than mean. Coming to the third measure, mode. Mode is dealing with what? It is dealing with the number that is appearing more often or which has the highest number of repetition in the data set. So it is actually it is simple to identify uh, the mode because you simply need to find out the highest frequency and that will be a mode. And another thing is it is very good for categorical data, to dealing with the categorical data, even for nominal data. Obviously, nominal data is a part of a categorical data. Categorical data such as the most popular shoe size, best shirt size, or most demanded suites, for example, and other things like when you are more concentrated on the numbers. So, what are the key learning about the mode? The data mode is suitable when you are looking for the standard things, right? And mode is okay with the categorical data, but and also with the numerical data, obviously, unlike mean, it is okay with the categorical data. Okay, and mode can be unimodal, bimodal, multimodal, or no mode at all, depending on how many uh, top frequencies are there. If there are two top frequencies, then we can say it is a bimodal, right? Coming to the next part of this discussion, one dataset, three answers, which means that for a single dataset, I can obtain all three measures of central tendency, mean, median, and mode. So I can get the mean also, I can get the median also, and I can get the mode also. But you have to decide according to the data obtained, which is a more suitable measure. And you have, while deciding which is a more suitable measure, you have to look at the pros and cons of the different measure of central tendency, all these three measure of central tendency. So there is a data on your screen which is like 4, 7, 7, 8, 9, 10, 10. If I want to find out the mean, what I have to do, I have to just add up the values, which is 55, and divide it by number of counts, which is 7. So 55 by 7 is 7.9 is the mean. Median is like positionally, which is in the mid. So 4, 7, 7 are on the left hand side, 9, 10, 10 on the right hand side, and 50th at which value is at the 50th percentile, which is 8. 8 is in absolutely in the middle. So I can say the median is 8. And what about the mode? Mode only deals with the repetition. So 7 and 10s are repeated twice. So it is a bimodal case where two values are repeated again, 7 and 10, and therefore my mode is 7 and 10. So is the data symmetrical if I ask you? So what are the conditions for data to be asymmetrical or normal? All the three measures should be equal. Mean is equal to median is equal to mode. However, mean and median and mode are not very far away. So the kind of distribution I'm having is near normal, but it is not absolutely normal because all three measures are not the same. So the graph which I'll get is somewhat like this. It is near, I mean, 7.9, 8, almost median is almost equal, but even mode is 7 and 10. It's not very far away, but it is not perfectly normal because all three are different. But if the values are okay and it is equal, then this is called a symmetrical distribution. And obviously, when your data is symmetrical, then mean can be chosen as a measure. Otherwise, if it is skewed, then median and mode will help you. Okay, coming to the shape again, symmetric distribution. All the three measures, mean, median, mode, are equal, and this is actually widely used in statistical testing. And this is one of the condition which should be met, that your data should be symmetrical or normal. Okay, then coming to the second type of shape, which is called right skewed. In the rightly skewed data, mode come first, followed by median and then mean. Because mode is dealing with the pickedness, highest frequency, because frequency is on this axis, y-axis. So highest frequency is mode. In this case, highest frequency comes first. I mean, whatever value is there, there lies the highest frequency. But more observations are tending towards the right, taking the mean upward. And median is obviously a positional mid. So half of my graph is this way and half of my graph is this way, and median is that. So this is called right skewed, when mean is higher than median is higher than mode, right? So mean is at the top, is greater than median, is greater than mode. And if it is the reverse case, like mean is less than median is less than mode. So mode is at the higher value on x-axis, higher side on the x-axis. So highest frequency is on the right hand side, and then comes to the then comes to median always is in between, and then comes to mean. So mean is lesser in value because on x-axis it is lying on the left hand side. This is called the case of left skewed or negatively skewed. This we will be discussing more in detail when we will be talking about the kurtosis and skewness in the coming lectures. So as of now, the property which I need to remember is like in a symmetrical distribution, all three measures should be lying at the center, and these all three measures should be equal. But if my data is positively or negatively skewed, it actually all these three measure of central tendency will not be equal. And if my mean is greater than my mode, then I can say it is rightly or positively skipped. And if my mode is greater than my mean, then I can say it is negatively skipped. Coming to the outlier test, and why outlier is important? Because my mean is highly affected by the outlier, whereas median and mode are not that much affected by the outlier. Outlier is the single most important practical difference. For example, income, house prices, reaction time are the classical cases of where median beats mean. So when outlier is there, median is a better measure than the mean. Like we have seen there. So there are five employees and their salaries are given. So employee A, employee B, employee C, employee D, and employee E. So employee is nothing but CEO. I mean, CEO is getting very much high salary, and because of which, what will happen? Mean will pushed up, and the average salary in this case is dragged upward by the CEO's salary, and the average salary comes to 92,000. However, majority of the employees are getting salaries near 40, right? And therefore, the median stays at 42,000 rather than pushed upward like mean because of the CEO's salary, which is outlier in this case. Mode also resists to outlier like median, so it is also okay with the outliers or extreme value. It is robust with the outliers or extreme values. So whenever there is outlier in the data, then mean fails to give you the true picture, and median and mode becomes a alternate measure or better measure of central tendency. The mode and median are more reliable than the mean in this case. So if we compare them on one slide, then coming to the data type. So where mean is good, if you are dealing with the interval data or ratio data. One median is good when you are dealing with the ordinal data. Okay. uh, or categorical data. One mode is good for any data. Mode is okay because mode has to deal with the frequency. It has nothing to do what is there on the x-axis, whether it's categorical or continuous. It is dealing with the highest frequency only. So whether measure uses each value in a data set. Mean, yes. Mean, while calculating the mean, you have to add up all the values and divide it by n. But median will not take every value into consideration. Rather, it is focused on the mid, okay, which is positional mid. So whether the value is 5 or whether value is 15 when your median is 20, both have the equal rank, like less than 3. So it both will be placed at 4. If another remaining values which are less than median are less than 4. Coming to the mode again is it not uses every value. We are simply focusing on the highest frequency and we are taking that value into consideration. Whether affected by outlier, mean, yes. Strongly affected by outlier, median, no. And mode, obviously, mode is also not affected by the outlier. Coming to the next part is next item is like unique answer. Whether mean give you a unique answer? Yes, mean will always give you a unique answer. Median 2 will give you a unique answer. But for mode, it can be 0, 1 or many others, right? Coming to the shape, mean will be suitable when when your shape is symmetric or you are dealing with a normal distribution. Median is okay with the skew data, and mode is also okay with the skew data or categorical data. Actually, mode is suitable for both type of measure because mode have a different uh, inclination. Mode is looking for the highest frequencies. Coming to the last part of this comparison, which is algebra friendly. Mean is algebra friendly, obviously, because it carries all the mathematical properties Median has a limited algebraic properties because it is not taking mathematical properties into consideration. Rather, it is concerned about the relative valuation, and mode is not at all suitable for algebraic calculations, right? So, comparing all these three, in one word, I can say mean is very good measure if your data is free from outliers, if your data is symmetrical or normal, and if your data is like continuous or carries some mathematical properties, and it is the best measure in that case. But if your data has a limitations of outliers, limitations of skewness, then median and mode become more appropriate measure. And again, median is a good measure, and mode has entirely a different uses. It focus on the repetition, or you can say the frequencies, rather than the position, rather than the values or the value, right? So all these three measure have their own importance and limitations. So when should you use each? Use mean. Data is roughly symmetrical with no extreme outlier. Example, test score, height, temperature, repeated measurement, or you are measuring the marks, you are measuring the weights, anything where you need a data to be continuous. Median is good when your data is skewed or you have the outliers. For example, like household income, house prices, reaction time, satisfaction level, or you can say your improvement in health, etc. And then coming to the mode, you can use mode when data is categorical, or you want to find out the most common value or most repeated value. So example, your favorite color, your shoes, your size, most sold product, most demanded product, or which is a more demanded design, etc. So the rule of thumb is if you hear income, price, or wealth, reach for median. For categories, mode will work. And if the data is numerical, go for mean. So what are the key takeaway from today's lecture? The key takeaways are like mean uses all data but chases outliers. It is good that mean represent all the values in the data set because it takes into consideration all the values while taking the total and dividing it by n. So it is a representative of all the values, unlike median and mode, but it has a limitation of outlier, right? So coming to the median, median is robust and reports the true middle. It is good for skew distribution. Outliers are there, not a problem. And it is also suitable for categorical data handling. But the median is not very much suitable when you are using this representative of central tendency in algebraic expression or mathematical calculations. Because it is, and obviously it is not a true representative of all the values in the data set, median. Okay, so median has its own limitation and own advantages. Coming to the mode, the mode is the only average for categories that uses that focuses on the repetitions, or that actually is suitable for categorical data, and that categorical data, and it deals with what highest repetition irrespective of uh, outliers are there or not, satisfaction level. Mode will not be suitable, but for in industry, mode is widely used because you are always interested which product, which type of color, which type of design will be liked by the customer more often. Accordingly, you produce your product. Mode is very good. So compare the graph to detect skewness. What you have to do, you have to find out whether mean is greater than median and mode, or whether these are equal. If equal, data is skewed. If mean is greater than median or mode, you can say it's rightly skewed. And if mean is less than median and mode, then you can say it is negatively skewed. So remember, you have to keep all these properties of all these three measures of central tendency while choosing which one is more suitable measure of central tendency. You have to take their properties into consideration, their pros into consideration, and their cons or limitations into consideration. And accordingly, you have to choose the best measure of central tendency. So with this, we are winding up with the central tendency in this week. And in the next class, we will be covering another important thing, which is very important when to draw a complete picture, because measure of central tendency is not complete in itself. You need to have the clarity about the dispersion or distribution of the data. Whereas central tendency give you one single representative of all the values in the data set, but it will not tell you how these values are spread it in a data set, or are how these values are deviated from the averages. To capture that limitation, we have the measure of dispersion, which we will be covering in the next week. Measure of dispersion will help you to handle the outliers also, and it help you to find out how much possible deviation will be there. So whenever you are dealing with the uncertainty or risk, that will be helping you. What? The measure of dispersion. So that will actually make the descriptive statistics more meaningful. If I use central tendency along with measure of dispersion, then that will give you a better picture of the descriptive statistics rather than an incomplete picture. One, if I use only one measure, that will give you an incomplete picture. So that is all for today. See you in the next week where we will be starting with the measure of dispersion. Thank you.